in a finer level of detail. And then when you look at these diagrams, sometimes it goes click. You know? People sometimes say, that could be it. You know, it's like we say in English, the penny drops. Ting. It's like, oh, that's the problem. Let's look at that. So, in other situations, that doesn't happen. And you talk and talk and talk. You can't find the problem. You have to look deeper and deeper and deeper. But sometimes, if you get the right people, they'll say, do you know what? I'm not sure about the test data we're using here. Do you know what? If we use the wrong test data in our environment, it could be that it will give us false passes. In other words, the tests that we are running are saying, test passed, and actually there's a defect there that we didn't find. And that could mean the results of our test is saying, everything okay, but there's a defect there. And guess what? That caused our in-flight emergency. It's a chain of different things that hang together that you try and identify here. It's problem-driven. Sometimes it's easy to see them. Sometimes you draw these diagrams forever and ever and you don't find anything. But it's visualization of the problem area. And it's a very useful analysis technique. And if you're ever working in safety critical software projects, then you can use this kind of thing to predict possible chains. So you start with a list of horrible things that can happen. My aeroplane crashed. Yeah? And then you say, what could cause that? It could be caused by test results being incorrect. It could be that you trace backwards the other way. Do you know what I mean? And if you can trace a path from something that you don't want to happen, if you could trace a path all the way back to some root cause, you have found something that you must fix. So your test process improvement would be, you must make sure that the test data you are using is realistic. Okay? Not simulated or not, because that could result in our problem. So you can use this technique to evaluate things that have happened, or you can use it to maybe predict if there's a possibility that this can happen. And that's what FMECA is. If you ever hear that, failure modes evaluation, that's what they do. It's nothing other than a whole round of people dreaming about horrible things happening and then trying to see if there's a way that that horrible thing can happen in reality. Okay? It hasn't happened yet, thank goodness, but you're just looking to see if it could. So think about those things when you're analysing. Now, that's a lot. I'm asking, that's a big ask. I've given you 2 slides. 2 slides on root cause analysis. And there would be professors of root cause analysis that would say, you crazy? You can't do root cause analysis in 2 slides? Well, of course you can't. But now you've seen an example. Now you've seen what you can do. And now you have understood, if you get a major failure, that's how you can analyse what happened so that you can improve your process afterwards. Now, you can use also, for test process improvement, an approach that is based on metrics. You know what metrics are? Do you collect metrics, any of you? What kind of things do you collect? What kind of things do you measure? Defects?
False alarm.
False
alarm.
False alarms? Number of false alarms? Anything that's measuring something. Number of test cases executed. Number of test cases passed or failed. Anything that you can measure, okay? They're metrics. You can collect those and you can analyze those. And therefore, when you are actually using metrics, you can help your test process improvement by saying, well, this is what we would like to achieve. This is our objective. We want testing efficiency to improve by 20%. That's a goal. And you ask yourself by saying, well, okay, what questions do I need to ask here? How much did our testing cost? Okay, that's something. What else could you ask? We've got an example coming up. You'll see in a moment. You start by asking yourself questions. How would we measure if this goal has been achieved? The questions you would ask. And then you choose the individual metrics, the individual things that you measure that you need to answer those questions. And you build up a structure. And this is called a GQM approach. Now, it's better, actually, to see an example. I'm hoping there's an example coming up. Yeah, there we are. An example. That's our goal. For the system testing of major releases, we want to increase the percentage of severity 1 defects found by test cases by 50% compared to defects reported in production. Well, that's nice and measurable. You need to make your goals measurable. And what questions do you need to ask? Well, how many severity 1 defects have actually been reported within 3 months of the software entering production? That's the question. How many? How many severity 1 have been reported in system testing? Those are 2 questions we need to ask. And the metrics we need are defects reported in production, defects found in system test, and defects not found in system test. Okay, so there's different things that you're measuring so that you can answer questions yes or no, so that you can decide, have I achieved my goal or not? This is useful if you are collecting metrics in your project. If you have a test management tool, for example, if you have ALM, you can generate a lot of these metrics, and with that information, you can actually use that information in this GQM approach to actually achieve your goals, your test improvement goals. That's the idea. Now this takes practice, guys. All right? This takes practice. It means that you've got to all the time think about measuring, about the goals that you need, about the questions you need to answer. It's a very structured approach. Very structured. What I see sometimes is people collecting not lots of metrics and they don't know why. So it's like they're really good here. Hundreds of different metrics. Loads of them. Aren't we good? Why is the question. Are you collecting those metrics? For what purpose? Well, very often the people can't answer that question. They are there, and it says in the book, I need to collect these metrics, but I don't know why. Well, I'm just showing you now how you can use those metrics. You can bind them in, you can use them in this kind of a concept to help you improve test processes because you're improving the test process by setting specific goals, just like this, and measuring if you've achieved it. That's really, if you get this set up properly, it's a really powerful tool for test process improvement because it's absolutely objective. You can see how you're improving. It's not just subjective, I think we're improving a bit. It's we know we're halfway there, or we know that we've achieved our objective. Halfway there means, well, we're finding 25% more. We're halfway there. It's useful to communicate this to your stakeholders. So you can adopt this analytical, metrics-driven approach. If you have an organisation where you have those metrics and where you have the ability to use them. Very powerful. And if you look up GQM in Google, you'll find a whole lot of stuff. Okay? Have a look at it. And you might think, oh, you know, this is like really complicated. It's not really. You can make it complicated, yes, but you can make it also very, very simple. But just link your metrics to your goals and you're done. That's the idea. So that's GQM. Now, you know, this is heavy. I'm sorry about this, but I've got to give you these overviews, otherwise I'm not giving you that information. Systems analysis is something that you can do if you have a complex system that's all interconnected. It's linked. Parts of those systems can be computers, applications, people, anything can be in this box, in these boxes. Well, not anything. Software, hardware, people mostly. And what you do is you identify the things that interact with other things. Okay, so your software is interacting with people and with the hardware. Maybe you've got different systems working with each other. Maybe this arrow here, maybe that's an interface between two applications. That kind of thing. You build up a picture. What information is flowing throughout my system? And sometimes it's just straightforward, end to end. It comes in here, it goes and comes out. Easy. But sometimes those systems are connected in more complex ways. And systems analysis tries to identify areas in your system where there can be particular things happening. You're looking at loops in your system. Can you see any in that system there? Is there any loop that you can see where you say, well, it doesn't go from end to end, it keeps going around? Can you see that? Anything? Well, let's take it from up here. Okay, down here, up here, up, we're back again. Or down here, up, we're back again. Down here, oh no, that's okay, that's end to end. That's no loop. When you identify 1, 2 loops, you start to analyze. And you start to analyze to see what happens in that loop. And you start to try and identify any of these 4 types of loop. Okay? Now, as you can see, they can be good or not good. Okay, so have you heard of the term vicious circle? You hear it sometimes in normal life. Oh, that was a vicious circle. What it means is that something started bad, and step by step it got worse. It's like water going down a plug hole, you know, in the bathtub. Getting worse and worse and worse and worse and worse. That's a vicious circle. That's here. But those loops can also be constructive. It could be that things get better and better and better.